Hi there. Thank you again for joining us. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, and we have got a lot to talk about as always. This is a really interesting story to start us off. 2 exoplanets have collided. Apparently it happened on the corner of George Street and Martin Place in Sydney, and they weren't insured. We've got more interesting data from DART. See what I did there? And a paper looking at Australia's telescopic science future with a strategic partnership about to end. What does it all mean? We will tell you on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back again to throw furniture at us. No, to furnish us with his knowledge. It's Professor Fred Watson, astronomer at large. Hello, Fred.
You're on fire today, Andrew.
I don't know what to call it. Maybe not on fire.
It's turned in me. It's cost me my voice. Having a coughing fit. Excuse me. Yes, I am going to furnish you with any gems of information that I can drag up from wherever they happen to be lurking.
Very good. I appreciate it. Otherwise, it'd be a very boring show.
Yes.
Yeah. How are things? Everything good down in your neck of the woods?
Yeah, not doing too badly. The job that I do, which is a sort of vague job as a professor of astronomy, is getting busier and busier.
Yeah.
A lot going on. And we'll talk about some of that actually in this week's episode. But yes, all good so far.
Excellent.
As far as it goes.
All right.
Actually, I can tell you, I might have mentioned this to you last week. Over the weekend, I was down in Canberra because I was narrating some music about the sky given by a classical ensemble called the Griffin Ensemble, who I've worked with before. They are a sort of 8-piece altogether classical music ensemble. They're very popular in Canberra, and they do a work which was written by an Estonian composer who's now no longer with us, Urmas Sisask. Both the leader of the ensemble and I have met that guy a long time ago. But he wrote a big piece called Southern Sky about the Southern Hemisphere constellations. And they were playing excerpts from that in the 2 concerts that we gave on Sunday. And my job is to say a little bit about not the constellations, but sort of what they mean, what astronomy, what's going on in astronomy, just to add a little bit of, perhaps a little bit of structure to the program. And there were 2 sellout concerts. We had full house each time, and it all seemed to go very well.
Yeah, fantastic. Gee, that's different, isn't it?
Yeah. It's very close to my heart because classical music's always been my thing, and it's really nice to be able to participate in it at that kind of level.
Yeah, wow.
These are top class musicians,
And you say they're very popular in Canberra.
Yeah, yep.
That's difficult to do, to be popular in Canberra.
Yeah, I know. We did take when we started doing this. The very first time we did it, it was in the ruins of one of the telescope domes at Mount Stromlo.
After the
which got
fires.
burned down
Yeah.
a few years earlier, and it was really what an atmosphere. It was just in this circular building, which was a dome once, with the piers of the telescope. The telescope had gone; it was burnt, but the concrete remained, and quite spectacular. And that was the first time we did it. We've probably done it 20 times since. It was featured on ABC Classics a few years ago as well, so that we can kind of
Awesome.
probably find it somewhere.
Yeah, great stuff. Wow, what a venue too. And you just had to tear away all the police tape so you could get in. So yeah, that would...
Yeah.
Dear Droggy. Shall we get to it?
Yeah, let's get to it. Sorry to
Oh, no, it's really interesting.
That.
Actually, in our next episode, we're going to hear from somebody else who does something completely different, because we asked the question about, tell us more about your job, and they did. So we'll look forward to that. That'll be fun.
That's really interesting as well.
Yeah, it is. But first, let's talk about this fascinating discovery, which didn't happen near us, thankfully. 2 exoplanets have been witnessed colliding It wasn't a car crash, but probably a little bit worse in the scheme of things.
Pretty spectacular, I would imagine, if you were, at a ringside seat for that, or an orbit side seat. This is work that's come from the University of Washington in the US. It is a piece of research concentrating on a star which is 11,000 light years away. It's not nearby. This is kind of it's well in the depths of the galaxy compared with where we are. And I might tell you the name of the star because we should always give our stars names. It's called Gaia 20 EHK, and it's a bog standard main sequence, as we call them, star, a lot like the sun, and is like the sun, constant in its light output. So this thing's been monitored since 2016.
Okay.
Beg your pardon, since before 2016. The Gaia spacecraft is a what's called an astrometric spacecraft. It measures the positions of objects in space very accurately, but it also measures their brightness. And it's been going now for, oh gosh, I don't know when it went into orbit. I should check that. But anyway, Gaia 20 EHK was one of the stars that was monitored by it. And then in 2016, things started happening. And what basically happened was something that we expect when we have a planet in orbit around another star. You get a dip in brightness. That's how, we've talked about this many, many times on Space Nuts. It's how you discover that stars have planets going around them, because the planet passes in front of the star. It drops the brightness of the star very slightly, and you can measure that. And if it does it again, months or weeks or days, sometimes later, then you can identify it as being due to a planet going round this star. And so we happen to be looking along the plane of the orbit of the planet. That's the trick. That's the statistical bit. But it turns out there's still a lot that you can discover doing that. Anyway, 2016, it had 3 dips in brightness over a matter of years. But then in 2021, and I love the description by the lead researcher on this work, it went completely bonkers. A quote says, "I can't emphasize enough that stars like our sun don't do that." So when we saw this one, we were like, hello, what's going on here? And by bonkers, he meant that there were many, many dips. It's just sort of, it wasn't a steady, slow dip and then a coming back to brightness. It was almost like a flickering of the light of the star. And what they assumed from that, the research team, was that this is probably the result of a lot of rock and dust passing in front of the star as it goes around in orbit. Meanwhile, the sort of steady dips have disappeared, and all you've got is this almost flickering. And so what this is being interpreted as is that 2 planets, which caused the original dips in orbit around Gaia 20 AHK, collided. And we have caught that, by these observations with the Gaia spacecraft. So those planets are no more, but what we've got is a cloud of large chunks, probably, of debris, which is causing the flickering. And the bit of this that I really like is that they didn't just say, oh, well, that's the end of that. We know that's what's happened. What they did was they also observed this star in infrared radiation. They used a different telescope to observe it with infrared. And let me quote again from the lead author. The infrared light curve, which is the way the light varies over time, the infrared light curve was the complete opposite of the visible light. As the visible light began to flicker and dim, the infrared light spiked, which could mean that the material blocking the star is hot. So hot that it's glowing in the infrared. And that's the kind of the smoking gun, because if you're looking at the debris of a collision, this is a very violent event. what you would expect is for that debris to be hot, and it is hot in the infrared. It's visible in the infrared, revealing that it is actually hot. So the way they're interpreting this, and another quote from the lead author, Andy, let me try and pronounce his name, or pronounce their name, I should say. It's Zanidakis. Hope that's all right.
Close enough.
Yeah. The quote is, that could be caused by the two planets spiraling closer and closer to each other. At first, they had a series of grazing impacts, which wouldn't produce a lot of infrared energy. Then they had their big catastrophic collision, and the infrared really ramped up. And so the link that these researchers are drawing with our own solar system are, I think, in many ways quite profound, because what we might be seeing there is a similar event to the one in which the moon was created. Again, something we've talked about a lot, the fact that perhaps 4.5 billion years ago, very early in the history of the solar system, an object about the size of Mars, which we call Theia, collided with the young Earth and lifted clouds of debris, which eventually coalesced to form the moon. So that is... if we've seen something like that actually happening, as we seem to have done with this particular star, maybe there is an exomoon on the way being formed as we speak, as a result of these collisions.
Of course, 11,000 years have passed since the event.
Yes, that's right.
We're only seeing it now, but it's already 11,000 years since that happened. Still can't get my head around that stuff, but so who knows what's going on there? It could create a moon, it could create a much bigger planet, it could just become an asteroid belt. You just don't know, do you?
That's right. That all of those are possibilities. Unfortunately, it'll probably take, as they say, it'll take a few million years for all this to settle down, to let us see kind of, what actually has happened. So in a few million years' time, Gaia will probably be defunct by then, but we might be observing it by different means.
And I looked it up. It was launched in 2013 and got down to business in 2014. So... So that's a couple of years of observing this star when it did nothing, and then suddenly you started seeing these dips. Yes, went weird. Very strange. Another interesting coincidence about Gaia 20 EHK is that apparently that collision happened 93 million miles from the star, which is pretty much the same distance we are from our star.
150 million kilometers. That's correct. Yeah. So it's that's right. Which I thought was an interesting fact as well, just as a coincidence. But what that means is, because it is a sun-like star, and you've got this going on 150 million kilometers away from it, the same distance as we are from the sun. What's happening there might almost mimic what has happened here. In our solar system, that yes, you might end up with a Earth-like planet and a moon. That's in a few million years' time.
Well, we'll get back to that then, I suppose.
Yes, we will. We'll return to that story then.
Yes.
There may be more news. I mean, it's clearly this is it's a big story in the astronomy world. It's such a rare event to see something like that. I think there will be more studies, and we might have more information coming out of it. Not in a million years, but maybe within the next few months.
You never know. All right. If you'd like to read about it, it's on the space.com website, but you could also read the entire paper, which will take you a couple of billion years. It's in Astrophysical Journal Letters. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, NordVPN. Now, if you've ever felt like your online privacy is slipping through the cracks, then you're not alone. Hackers, scammers, harvesters, they're all out there trying to get your private info, whether that's your passwords or your personal details to sell on the dark web, or to use themselves to access your bank accounts, credit card details, and who knows what else. But you can protect yourself with NordVPN. You can take control at home, or more importantly, when you're out in public using free Wi-Fi. Right now, using the exclusive Space Nuts offer, you can receive 4 extra months for free on a nordvpn.com plan. NordVPN encrypts your internet connection, hides your IP address, and offers access to over 7,700 servers around the world. Plus, with features like Threat Protection Pro, MeshNet, ultra-fast speeds via Nord links, your digital life stays private and efficient. So don't miss out. Visit nordvpn.com/spacenuts and enter the code SpaceNuts to claim this deal. Remember, there's a 30-day money-back guarantee, so it's risk-free to try. Stay safe, stay private, and browse with confidence. That's nordvpn.com/spacenuts.
Hey, that's one of the better sims, believe me. We've had a couple of cardiac arrests down here too, Pete. There wasn't any time for that up here.
Space Nuts.
Now, it was only a week ago, maybe 2, where we talked about some interesting data that came out of the DART mission, that impact on a little moon orbiting an asteroid. And it's the gift that keeps on giving, Fred, this particular mission, because there is even more information that's come out. And this is really strange, this one. I would not have considered this, but there it is in black and white.
Purple and white, as I'm seeing it as well.
Could be purple and white.
Purple and white, yes, which is the color coding of the image that is the story that we're talking about. So yes, DART, the double asteroid redirection test, very successful collision of a little impactor, 600 kilograms. I think you corrected me on last time we spoke about it. And that actually shifted the orbit of Dimorphos, a little moon, 170 meters across, around its parent asteroid, Didymos, which I think is about 700 meters across. And it changed its orbit by 13 minutes, the orbital period. So a successful, really successful mission. We spoke last week about the fact that not only had the impact changed the orbit of Dimorphos around Didymos, it had also changed the orbit of both of them around the Sun by a tiny, tiny amount, but enough to be significant and enough to mean that maybe there is hope that one day down the track, if we really were faced with a prospect of an asteroid impacting the Earth, there might be things we could do. But the latest comes from some research, University of, I think it's Johns Hopkins University and University of Maryland. And what they've done is they've looked very closely at the images of Dimorphos, the little moon, which of course was captured by the onboard camera on DART, getting bigger very rapidly as DART hurtled towards it at 6 kilometers per second for the impact. And the last few images of that, of course, are very, very detailed. And so what these scientists have done is they've said, we wonder if, and I should explain what Didymos looks like. It's what's called a rubble pile. It just looks like a pile of dirt with boulders all over it, some of them quite big, with no real structure to it, just a potato-shaped object with lots of boulders on and clearly dirt and debris at very small scales. So what they wondered was whether there was any structure that would be visible, sort of underlying structure in the shape of that moon. And it's some really neat image processing. They've taken away the shadows of boulders and taken away the images of boulders. They've done a sort of search algorithm for the things that kind of would hide any underlying structure. And sure enough, when they did that, they revealed a whole set of streaks on the surface, and quite marked streaks, many meters long, all of which seem to basically originate from one point on this moon's surface, which, as I understand it, is the point that corresponds to the direction to the parent asteroid, Didymos. because it's tidally locked, Andrew, the Dimorphos always keeps the same face towards Didymos. That's the normal situation with something like that. And what they're interpreting this as being about is mere material being transferred from Didymos to Dimorphos and sort of landing with a splat on the surface of Dimorphos and causing these streaks to basically emanate from the point of impact. What they are saying is that it's a cosmic snowball fight. That's SciTech Daily's words. And so it is very, very intriguing. And they've done experiments to show that, yes, if you splat cosmic snowballs on a surface, you get these streaks. But the mechanism for this is something that they've hypothesized, but it probably is the mechanism for what's happening. And it relies on the Yorp effect, which I have heard of before, but I can never remember what it stands for. And the reason for that is that it's 4 names, Yarkovsky, O'Keefe, Radziwiłłki, and Paddock. YORP, the initials of those. I'm not going to try and attempt it again, but the Yorp effect is where if you've got an asteroid, small asteroid, sunlight that's falling on it, the sun's radiation, actually increases its rotation rate. It sort of spins it up. And as that happens, if you've got loose material near the equator, it can actually be flung off. That was one of the early hypotheses for how the moon was formed, that the Earth, when it was born, was rotating so quickly that centrifugal force lifted stuff off its equator, which eventually coalesced to form the moon. It was that theory was due to the son of the inventor of evolution. And I can't remember the son's name. Never mind. It's a couple of famous people. Charles Darwin's son. I've forgotten his name. Charles Darwin's son was an astrophysicist or an astronomer, and he suggested that was the way the moon had originated. And we now know it's not. The Earth never rotated fast enough to do that. But Didymos might have rotated fast enough to release material from its equator and splat it towards the little moon that it has in orbit around it. So, so remarkable, really remarkable piece of work.
Yeah. As for Charles Darwin's son, well, you've got a few to choose from. There's William, George, Francis, Leonard, Horace, and Charles Jr. So take your pick.
Yeah,
because he and his wife had 10 kids.
It might have been, well, there you go. It's evolution for you. I think it might have been William. It's probably very easy to find because the younger Darwin, whichever one it was quite prominent in the world of astronomy. He
was first born in 1839. William Erasmus Darwin, eldest child.
Right, okay.
Yeah, although it says he was a banker.
Oh, well, that might mean we've...
hang on. It'd be George, because he was a prominent mathematician and astronomer.
That's it. Okay.
So George Howard Darwin.
Very good.
Yeah.
We got there in the end.
We did eventually, yeah. Now, I did have a bit of trouble with you breaking up, so I missed a couple of bits and pieces.
Sorry.
No, that's okay, but these things happen. It's the internet after all. It's perfect. Did we finish?
No, well, just going to make one more comment. There is a spacecraft called Hera, which is going to visit the Didymos system. So we should see more evidence of this kind of thing. There'll be better images down the track than what we've been working with so far. So I think this is a story that we'll revisit at some point down the track.
Very good. I must say the image that they've published on scitechdaily.com with that colour impression makes it look like a passion fruit.
It does, yes. Yes. There you go.
I've got always
must be a link to there as well.
You know, you've got to create mind pictures with this sort of thing. So there you are.
Yes, you do, which is very, yes.
It's a bit bigger than the standard passion fruit, but yeah, probably not quite as nice. Yeah. You can also read that article in the Planetary Science Journal. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Space Nuts.
Our final story, and this sort of is a pretty serious story in terms of the future of telescopic science in Australia. And it's all about an arrangement or an agreement. I'm trying to think of the word, a strategic partnership maybe between the European Southern Observatory and the University of New South Wales, or Australian telescopic infrastructure. But that's due to end, and there's a risk that we might sort of be left high and dry. Seems to be the angst of this story.
That's correct, yeah. So what's prompted this? This is something that I've been deeply involved with for the last 2 or 3 years. So you're absolutely right. In 2017, it was the federal government that underwrote this. The Australian government entered into a strategic partnership with the European Southern Observatory, which gave Australian astronomers access to, first of all, the four 8.2-metre telescopes of the VLT, the Very Large Telescope down in Chile, and a number of other ESO telescopes as well were included in that deal. One that wasn't was ALMA, the Atacama Large Millimetre Array, in which ESO has a share, but the others were, and it's been absolutely transformative for Australian astronomy, because the biggest telescope we had available as of right before that was the Anglo-Australian telescope, a 3.9-metre telescope, still doing great work, but it's only half the size of the world's largest now, and it's on a fairly indifferent site. They've lost the last 2 nights because of cloud. That's very typical. Whereas that just doesn't happen in the Atacama Desert. They lose virtually no time to cloud. So you've got exquisite image quality because of the lack of atmospheric turbulence. So that for many years has been the holy grail of Australian astronomers, wanting association with ESO. Australian astronomers every 10 years put out a decadal plan. A new one has just been released last year. But for the last 3, I think, membership of the European Southern Observatory has been top of the list. And in fact, we nearly got it back in 1996, but that didn't quite work out. The strategic partnership was a special deal, and it was sort of almost like a try before you buy arrangement, with the hope back in 2017, that by the end of the strategic partnership, Australia would be in a position to enter into full membership of the European Southern Observatory rather than just this partnership. So that was the bright hope. 10 years have gone by. Sorry, I've got frog in my throat about this. 10 years have gone by, which have been very successful for Australian astronomers. But we're now reaching the end of that deal. It ends next year, in fact, at the end of next year. And in fact, this July is the last deadline for which Australian astronomers can apply for time. So it's really, the pointy end of this is coming up. European Southern Observatory, sorry about that, is very keen for Australia to become full members. It's sort of looking as though Canada might be as well. They might be accessing to full membership. Not sure about that. But Australia, of course, all Australian astronomers are keen. The European Southern Observatory is keen. What's the problem? The problem is it's quite expensive. It's an expensive venture, and your annual subscription to ESO depends on your gross domestic product. And ours is high enough that it means that our fee for membership of ESO is relatively high. It's $40 million a year. That would be what it would cost for us to join ESO. Now, the problem at the moment is we're in an era of fiscal limitations. The governments, federal government in particular, are trying to reduce costs. And, when you put it against a hospital or something like that, $40 million a year is quite a significant amount. But what the press release that's just been released by the University of New South Wales, which is why you picked that up at the beginning, it's drawing attention to an economic study by a very well-respected economist in Australia, Professor Richard Holden, who's also at the University of New South Wales, hence the press release from UNSW. He has shown that far from it being a luxury item for governments to fund astronomy and to include things like membership of the European Southern Observatory, far from it being a luxury item, it actually generates considerable revenue. And just what we do now, this comes about because astronomy stimulates research into high-end instrumentation. Optical instrumentation that's developed here in Australia is at the top of the list on a world scale. The instruments for astronomy and space science, and that effectively stimulates industry to join in with this and puts new inventions out there. And so this quite rigorous analysis of the benefits of being in astronomy by Professor Richard Holden has shown, and this is his paper that's just been published, it shows, let me read. There is a strong case for membership in the ESO as an investment in basic research. While there have been numerous attempts to quantify the economic returns to Australian university research, this report concludes by taking a novel approach based on endogenous growth theory. This produces more rigorous and plausible estimates of the economic value of existing astronomy and astrophysics research in Australia. You can see Geordie agrees with all this. And the bottom line is, what comes out of research in Australia, $330 million per year. So what he says is at $330 million per year, this is an exceptional return on the 184 tenured and 627 total scholars in the field of astronomy in Australia. Yeah. So a small group of people are generating a huge economic return because of the research that they do. And if you're putting $330 million per year out, then a $40 million fee to be part of ESO seems like quite a small fee. And what that does, though, is gives Australian astronomers access to the very finest facilities in the world. We can build instruments for them. We can do research with them. And as I said, all these spin-offs generate that kind of figure. And one last point in this, if I may, Andrew, I'm sorry, I've rambled on a bit as I do. We love Australia, of course. Thank you. Australia, of course, is one of the main contributors to the Square Kilometre Array Observatory. So Australia's radio astronomers are going to benefit enormously by access when that facility comes on stream towards the end of the decade. Part of it in South Africa, part of it in Australia, the SKA Low facility, the biggest and best radio telescope anywhere in the world, the two halves of it. Because Australian astronomers have access to that, it's always been seen that the SKA, the Square Kilometre Array, would be entirely complementary to the next big thing that ESO is building, and they're well underway with it. And that, of course, is the ELT, the Extremely Large Telescope, with a mirror 10 times the diameter of the Anglo-Australian telescope, 39 metres. When that starts producing data, 2029, I think, is currently the date. It will revolutionise astronomy. It'll absolutely revolutionise astronomy. And with our astronomers here having access also to the world's best radio telescope, those two facilities dovetail perfectly to give you absolutely pole position on the world stage of astronomy. So it makes that $40 million a year look a lot more modest. But the bottom line is the decision that has not yet been made. That's the main thing. So the minister's still considering this.
Yeah, but you're talking politics here. So the left hand might not know what the right hand's doing. So, someone will say 40 million, no way, not knowing that 330 million is being generated.
Yeah, that's right.
Danger,
which is, that's why I'm talking about this paper, because that is a very compelling argument for, actually the government stumping up the joining fee. Maybe it'll happen. We defer to the Minister for Science and Industry and Resources. We'll see what he has to say.
Indeed, we will. If you'd like to read about that, you can find it at the University of New South Wales website, where they've published the article. And that's about it, Fred. Well, I think we're done.
We are, yes. And maybe we'll end on an optimistic note that maybe one day you and I will be talking about the ceremony that allows Australia to join ESO. Who knows?
That would be wonderful. Yes, indeed.
It would.
Fred, thanks so much. We'll catch you on the next episode.
It sounds good. Thank you, Andrew.
Professor Fred Watson, astronomer at large. And don't forget to visit our website in between episodes. You can do that at spacenutspodcast.com or spacenuts.io. Have a look around, visit the shop. Maybe you'd like to become a supporter. You can do that by clicking on the Support Our Podcast button, or you can leave us a message or a question through the Ask Me Anything tab at the top. Just have a look around even. That's about it. And thanks to Hugh in the studio. Although he couldn't be with us today, he went and raided his piggy bank to see if he could scrape up $40 million so that we could become full members of the European Southern Observatory. But I haven't heard back from him on that. I think he ended up at JB Hi-Fi, actually. Anyway, from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.